If you're trying to figure out how to actually integrate AI across your software lifecycle, not just in one-off projects, QCon AI in New York this December 16th and 17th might be worth checking out. The entire conference is focused on the real-world side of scaling AI. You'll learn from technical leaders, senior engineers, and architects who've already been through it, the patterns that worked, the ML ops pipelines that scaled, and what they do differently. The conference is built for senior practitioners who need actionable blueprints, not just buzzwords. Learn more at qcon.ai.
Hello everybody, I'm InfoQ Podcasts, an InfoQ editor, and I have in front of me today Jenish Shah, one of the engineers from Netflix that are making sure that our movies are streamed each evening and keeping us in the couch. Thank you for that, Jenish. Can you provide us an introduction and a more appropriate title for you?
Sure. Thanks for the brief introduction, Olympio. Hello everyone, my name is Jenish. I've been working with Netflix more than 5 years now. And before that, I was working for 3 to 4 years in Amazon, and before that, bunch of other companies. For the official title, I'm a software engineer, hardcore backend engineer. I've been developing highly scalable distributed systems for years now, and that's my passion, solving real-world problems, helping my stakeholders, making great movies, great content, so you guys can sit on couch and enjoy that.
The companies that you mentioned, the two of them, do have interesting global scale products. And those are problems that each of us wants to know more about. So maybe you can share a bit of your upbringing, your education. How did you manage to get to this interesting position?
Sure, absolutely. So I'm originally from India. I was born and brought up in India. Back in India around 1995, right? Those were the years where people started using computers. And one of the first industry where computers were introduced was the financial industry. My dad used to work for a bank, and he got to start using computer. He was pretty excited. I was good at mathematics, I was good at analytics, and my dad just told me, it's pretty exciting to work on it, even if you want to play games. And eventually around, I think it was 99 when my dad got a computer for me and my brother. I started using it. Obviously, I was not writing any kind of code, to be honest, right? I was playing games to start with and then playing music. But while doing that, I was amazed by what all stuff computer can do. Now, in India, the education system, after you complete 12th grade, you decide what path you want to take in your career. So 2000 was the year where I had to choose. So it all aligned, and I was like, okay, if I'm getting opportunity in computer engineering, right, why not I just go with it? And then I started getting into data structure, and it got me more and more excited. I know many people hate it, but I do love it, right? And one thing follow another thing. I completed engineering, got into good companies, starting with Oracle. And then eventually I reached here. And throughout the path, I met many great engineers and learned quite a lot throughout this journey of 20 years.
Probably we had our first computer at home around the same time. That was the year for me as well. And actually, I was just thinking the other day, I was talking to some of my friends and I was explaining to them that probably I was around 9, 10 when I got my first computer at home. And actually, my daughter doesn't have access to one. We have a lot of laptops here, but she cannot say that it's one of hers. She's in a school that doesn't encourage screen time. And then I just realized that maybe it's just about time to do something about it. So we did some programming last year, like Python, and we did some Scratch even before. So we worked on that. But now it's the moment when I'm just encouraging her to do stuff herself, mainly through Python, because I found quite good resources. And that's quite cool. Thank you for sharing. Taking a step back, Netflix is synonymous, at least for me, to, as you said, distributed systems. For a long period of time, I was just looking and I was just amazed by what's happening on the Netflix blog and technology blog and all the stuff through Chaos Monkeys and all the things. And it was like pure innovation, things that are now used by a lot of other companies. But looking back, for a long period of time, microservices were synonyms with REST, and then REST was synonym with HTTP. Mm-hmm. And that's a big misconception. But it feels like in a village when somebody sees the movie, but not everybody sees it. And then somebody goes and tells the story, and then it's just getting diluted. But you're at the source of it. How do things evolve? How are you looking at microservices? Is it actually tied to HTTP? Is it only REST? There are other stuff. let's try to create something like maybe not like a blueprint, but a small definition, a small context from which we can evolve our conversation.
That's a good question, right? How microservices evolve, right? So initially, like if you go years back, then there was no concept of microservice. People used to create one service and it used to handle everything, right? Then people realize, right, like if you start building more distributed system, not all the features coming out of your product require similar kind of a treatment. Some components require like high scalability, some components require high reliability, and more or less all components require that. But you have like a feature specific, domain specific use cases, and what you want to do is you want to carve out a separate small service, right? And that's why people started thinking about microservices. Why not we have a microservices? And again, to your point, microservice is not just about protocol. It's not just about, like one microservice talk with another microservice. They handle a bunch of a business logic. And what eventually happened is like to start with REST, right? REST was like a very standard to start with, and that used to be the like by default protocol. If you have your service exposed to the outer world, like hypothetically, right, I work on Amazon or Netflix, but if I have a third party calling my service to get any kind of information or even internal service, we always used to follow the rest. And then people realize, okay, one pill will not work for all this, right? Like what we need to do is like, okay, for external, REST gives a good structure, JSON kind of an output, right? Like it's easy to understand, easy to read. That makes sense. But when you have a lot of small microservices handling each business use cases, going REST is not the optimal way, right? It's not the wrong way, but it's not the optimal way.
You provide a lot of nuggets of information, so let's put them in context. First of all, when you're talking micro, it means we are just focusing on a business topic. You have a business domain, and then probably a handful of microservices are just attached to a given business domain, right? Then, as you said initially, HTTP was used because it was convenient and it simplified if we think about what was before. So, and that had a lot of junk around it, and it was very hard to just change stuff. And obviously it was a good change, but it was not the most efficient way because HTTP at that point, at least the HTTP 1.1, was not considered for those kind of things. Just think about it. We were just coming from the age where you had just plain text images. And then other protocols started appearing and you were just about to start with gRPC.
Yeah. So that's what happens, right? Like gRPC is highly optimal, like a highly efficient protocol to transfer information. And what companies realized and that software engineers realized, if I need to make my service efficient, and my service is also getting information from other services, I want to make sure the communication pipeline is also efficient and just not my business logic. And that's why people say, okay, let's do this. Like for internal communication, let's start using gRPC. That gives us the best mileage to solve our use case, to solve our customers and all those kind of stuff. And that's when I think to your question, like things started evolving. Now I see my same services have a REST endpoint, same services have gRPC endpoints because I don't just have an external consumer, I have an internal consumer, which has a different kind of an SLA, SLO expectation, right? And eventually, right, as industry evolved, people started thinking about, and I don't know if you want to touch on GraphQL right now, but people started thinking about like new paradigm of building application. Now, as a user interface, you want to build an application. Earlier, you used to go to one application and get that data. But now, because of microservices, there are many services own different kind of a business logic or business domain. And the UI or user interface more or less want to get part of the information from all those services. And that's when the GraphQL came, right? The GraphQL builds an interface on all those services. So UI just call GraphQL, and the GraphQL is smart enough to pull respective information from the different services too, so that UI can enrich the user interface.
Let me extract a couple of points on what you mentioned. So gRPC came as a solution to have things more efficient. And most often than not, from my knowledge, this is used for internal communication, and that's what you mentioned as well. And now to just go and use some fancy wording from the distributed landscape, this should be used for east-west communication, right? For internal services, as they're called by people that actually want to feel that they know about distributed systems, right? Then, if you're looking at a given moment of time, and probably I am expecting that, at least in my experience, where I feel that I don't need to have very chatty services, you need a way how to go against it. So what you're doing on the backend side, you want to be distributed to be scalable so that each entity or microservice service in this case can be scaled individually, and then you can use them wherever it's needed. But at points, let's say when working probably on the mobile side, because the mobile is more sensible to having chatty services, or even when it's about cloud and you don't want to have that, you can aggregate it. So you go against what you actually did on the backend side. And GraphQL was a solution for this stuff, where you just send the request, but behind the scenes through the middleware, the GraphQL middleware, it just aggregates all the information and then provides that so that you don't have to do a couple of back and forth, right?
Why not?
Great, thank you. I was just going through my mind while listening to you that it's so funny and such a beautiful thing in terms of open source and what the open source technology brings, because we are discussing about the concept that got started in ThoughtWorks, a company that is known for the nuggets of information technology industry that they provide, and that's the microservice. Then we're discussing about REST that came from a PhD thesis a long time ago, and it was tied to HTTP, that was an open standard and it still is for a long period of time, an open standard. And then we are discussing about gRPC, that's a protocol that was put together by Google and shared by so many people. And then we have GraphQL that comes from another FANG company, and that's Facebook. And all in all, a lot of the concepts of the distributed systems were coined and built by Netflix on a very powerful Java stack. Java has 30 years now, so it's something that came from Sun, and then now it's Oracle, and it's such a nice ecosystem to be. Okay, what I like a lot, and that's something that it's very important for me, is the part with the business, because in the end, technology should serve business. And this is one part of what we're discussing now. It's just plumbing. But the other stuff that is problematic is at points you're just getting tangled in the flow of the application and so on and so forth. How do you make sure that you you mentioned briefly SLAs and SLOs. So, I'll just stay on the SLA side of the things because SLOs are for you internally, so I shouldn't care about that. But how do you make sure you handle things properly with grace? Because in the end, that's what counts for me, right? And that was one of the benefits of the microservices, that if the service degrades, I don't know, I want to watch a movie. I know exactly what movie I want to watch, but I don't know, the search is not working or some other stuff. How do you see it from that angle? How you make things work as expected?
So when we think about microservice, right, like in today's world, in the fast-paced world, I think what we are trying to solve every day, right? If not every day, every other day, we try to come up with one new business use case, right? And then try to solve those use cases. And what happens is, like, more or less, we will keep building new microservices every now and then. And with all this out-of-box technologies, it's easier to build microservices. And that's what we have been doing. Now, to your point, like the degradation. So while most of our focus in building the business logic, right? Like I want to understand my business domain, I want to solve that problem. And when it gets solved, everything is fine. Hunky-dory, right? Nobody cares about how it is working internally. The problem is when things don't, and that's what I've realized, and I've been discussing with my colleagues, and I'll get to it in more detail, but when things don't work as expected, right? Like, okay, you did something or one service call other service and something unexpected happened, right? Like you are interacting with database went down. You are expecting some other input as a part of the request from the caller service, but they didn't pass the appropriate input. How do we take care of this kind of a situation, right? Because every business has a consumer, either it's an internal service or it's a user like you, right, who is watching Netflix. You don't always want to show, oh, something went wrong. Like sometimes giving extra context is useful, right? And that is pretty important, right? Like while you try to solve business cases, you also need to make sure, and which honestly kind of get overlooked for major number of time. Like when you are starting to build, you are more excited about solving business use case and overlooking, okay, what if things don't go right? Like, so providing the appropriate error code, right? Providing appropriate information when things don't work out fine is extremely important in my perspective, right? Like, it doesn't matter your caller is internal or external. Like, just think for an example, you are filling up some form on the hotel reservation website, right? You put bunch of information, you hit submit, and because you missed out on one of the text field mandatory, you hit submit, it says, oh, something is wrong. You get annoyed, right? Like, you don't understand what's going wrong. You require user-friendly error when you nudge user to take certain action. And it could be anything, right? So I think that's what I see. How we have to scale is both ways, from the business perspective and from the experience perspective.
I was asking about that because, as you said, there are two facets of it. One of them is you as the provider of the service, and then obviously you need to communicate out with the outside world what happened. And then on the other side, you as the developer that are calling another service, you should know exactly what should I do now. Wait, retry, just drop it, and all these kind of things. And I had a conversation earlier this year with Sam Newman, one of the persons that I'm quite known about the microservices background. And that was what he was saying, that it all boils down when you're looking into a distributed ecosystem to three things: retries, potency, and timeouts. So how often should you try, and what should be the timeout of the service to know exactly how to do it and not to overkill the service? And then probably you can have this flow based on error messages, right? So that's it. But if you're just thinking in a monolith perspective, well, that's pretty easy. You have one thing that interacts with the other one. It's just plain calls. But when you're over a network boundary, how are you doing that?
And that's what, like, I would like to get into a little bit of technicalities, right? Over here is like, let's just think, like, as you said, like a provider and consumer use cases, right? And I'm starting with the provider, right? What happens, as we were just discussing, over the period of time, we have started serving multiple protocols, even as a part of one service, right? And the protocols are the way to communicate information across wire, right? Across network. But your business logic more or less stays same. So you may have an API which is exposed over gRPC. You have an API which is exposed over REST, but both of them might be using the same business logic. Now, if something has gone wrong, like just hypothetically, let's assume like you are trying to book an hotel and that room is not available, right? Like 404, right? Like you were trying to do something, It is not available. I need to give that information as a provider, right? So that I want to make sure that, suppose Olympio is my caller, doesn't keep retrying, because if you keep retrying, it's not going to work out because that information is not there with me, right? Like, so I need to give them clear instruction. Now I have a business logic, which is same, which is identifying whether that room is available or not. And then I have to give that information back over REST, and I may have to give the same information over gRPC. Now, the interesting part is, with the adoption of different protocol, every protocol comes with a different industry standard, right? Like, these are the error codes in the gRPC, these are the error codes in the REST word, right? In REST word, if I don't find anything, I'll return 404, right? Like, it is a standard status code. 404 doesn't mean anything in gRPC. They have a separate status code, like it is not found or something. So what I need to do, and the onus on me, which is provider, and which is kind of a, I know it is, again, I keep telling, is an overload, right? Like, I need to, but still write a code to understand, okay, my call was on the REST, and now this situation has happened. I need to give the response code is 404. Or the same call was happened on gRPC, I need to give the status code as not found, right? So that means, to understand, as a good service provider, I need to understand that what I need to do is essentially is create an interceptor, which will understand, okay, the business logic failed. It is telling me something. I need to convert to a protocol specific error code before I respond it. So now that is the thing, right? Now let's look at the caller side. Like my caller, they are looking for the as accurate as possible information, right? Like if they are looking for 404, if the room is not available, if I can give them 500 is generic internal service error, right? Like, and if you don't handle things, more or less, you will run into that huge bucket of 500. If you are my caller and if you keep getting 500, you are clueless, right? Like, to be honest, like you don't know what has happened wrong. Is that something you can change so that your call will work, or is that something temporarily wrong at my provider's end? Like, what's going on? And it's not just you. You might have your callers. You want to provide that information to your callers, right? Again, I was going back to the hotel reservation page. You keeps getting, oh, something wrong. Okay, what are you going to do, right? Like, so user experience is the very important thing, not only in the case of the success when you can stream movie efficiently. If something goes wrong or user is doing something wrong while booking hotel, you want to give that information back to user, and the error codes are the one which are going to drive that information with the specific error message.
Okay, so usually looking at the very simple code, I don't know, you're reading a file in Java. What you need to do is to just wrap it in a try-catch. Obviously we're discussing about ancient Java because now Java is very cool and very thin and doesn't have to do a lot of stuff. But basically that's what lands in the programming language. And then if you have this reading from a file system in a method, you have two options. One of them is to catch the exception itself, or then bubble it up, and then it will just go and somewhere it needs to be handled. And now, in the distributed world, it's a lot more complicated because internal communication is usually done through gRPC. Probably outside facing is either through REST or GraphQL. And then out of a sudden you have 3 different protocols and each are different. And because we are elegant programmers, we'll not do something like if GraphQL do that, or if that, or it will have a different perspective. What's the solution?
So what I am doing, right? So I developed a design pattern being in Netflix, right? Like I think it was 3 years back or 4 years back, right? At some point of time. So what I did is, okay, now as a backend engineer or as a distributed service, I want to have my major focus on solving business logic and not writing a code which will keep transforming my error scenarios to the protocol specific error codes. How do I do that? So what I came up with is like, okay, in any system, if you divide your scenarios, right, like where things can go wrong, are 4 major buckets. One is like, okay, you got some input or you got a request and whoever is the caller is not authorized to make those requests, like kind of an authorization problem, right? Another bucket is callers are able to call, right? Like they're eligible to call, but they did not provide enough information. They provided wrong information to execute further business logic, kind of a validation problem, right? So that is another bucket. Third bucket is when my system has done something wrong, right? Like, okay, everything looks fine from the caller perspective. We are trying to process business logic. Something has gone wrong in parsing one of the file, which we are reading from the file system or something, right? So it's like my application business logic problem. And the fourth bucket is like when my service also depend on other service, other infrastructure piece. It could be database. It could be some other service, right? What if database has gone wrong? So like it's a dependency exception, right? So what I came up with is this design pattern where I create 4 different exception, like authorization exception, validation exception, application exception, and the dependency exception. Even in validation exception, come with the enums. And again, those enums have nothing to do with any protocol. And I'll come to it a little bit later.
Okay.
It's like you have a validation types. What can go wrong, like not found, out of range, or whatnot, right? They're all different. Now, these are the exceptions. So when I'm writing a business logic or anybody in my org is writing business logic, they don't care what protocol my business logic is getting called. If I find there is a caller did not pass enough information, I'm going to just throw validation exception without worrying what protocol is being used. What this design pattern, and I would consider this as a library, the library which I created, which exposes 4 exception, which anybody can throw. I also has an interceptor already inbuilt, gRPC, GraphQL, and REST. And what it does is like, if this library is consumed by any application, in that application throws suppose authorization exception or validation exception, this interceptor automatically come in a picture. They'll automatically identify, oh, this call was made over gRPC. And now validation exception is thrown with like a invalid user input. Now, what does invalid user input mean in the world of gRPC? It will automatically transfer to the appropriate status code and send it back a response. And the same thing will happen REST. So suppose that call was made on the REST and then validation exception would have happened like suppose room was not found and the validation exception was resource not found, right? Like the interceptor will convert it to 404 and send it back. So now what has happened after this, and now this library, at least in Netflix, is used by more than 150 services. And what is happening, like as a developer, generally you own multiple microservices. If this library was not there, you are writing this code in all these microservices, all these interceptors, all this exception and all that stuff.
Let me see how I can summarize it, because you get me very excited about it, and then it's hard to just push on that. So you just looked at it. As you know, just referring still to HTTP, that is probably the most common ones. You have these error codes that are quite known. It's the 4xxx exception, then there is the 500 and so on and so forth, right? And rather than just focusing on that, because each protocol has their own way of doing things, you just broke it down into logical steps or business-related steps as categories. Usually you have a problem with having access, and that's the authorization side. Well, oversimplified, because then I will not go for the triple A's and say that we have multiple things or whatever. But it's the part where it's the authorization, and then it's about the validation side of things. If something is not that is accepted, as you gave an example, not having the resource available, or an application logic, I would expect this to be something in terms of computation. Something is not working as you would like it to be. And then there was the fourth bucket, downstream dependency, that if there is a service that is not available. So what you said is that these are the main categories that are there, and it doesn't matter. And that's in terms of the logic part. And then in terms of the implementation phase, you're using an interceptor that knows what language each microservice is using. And then on top of that, it just takes it, refines it, and then provides the response as expected. So bubbling up in the right language.
Exactly, right? And consider you get all the stuff as a part of a one. And that's why I keep calling it a design pattern. It's not like a great invention or something. It is like everybody, all of us would know. But this is a design pattern which I created. Okay, put all the stuff in a library so that everybody doesn't need to write. Every service owner doesn't need to write the same logic. They can start using this library. And then after that point of time, they can always concentrate on business logic, keep throwing this exception when appropriate. Another thing which I want to call out is like, say industry standards are today, right? Like it keeps evolving, right? Like you start getting new granular error codes, and it has happened in HTTP world also, right? We started with a very low number of error codes. Now then it started bubbling up to handle more and more granular cases. Now, if suppose new set of error code comes, now it doesn't make any sense for all like companies like Amazon or Netflix, where there are thousands of microservices, to all of them to go and change that to handle this new error codes, right? You require such kind of a design pattern or library where you can just go at single place and say, okay, now validation exception has one more granular flavor. So people, when they start showing up, all these interceptors will start understanding this new error code and will convert it to it. So it's not just solving for me. And again, just to give you a little bit of my motivation, when I joined Netflix, I was working on a production suite, and I used to manage 8 microservices. And as soon as I had to start writing the similar kind of, I'm like, okay, now I'm doing something which is like a pretty boilerplate. It doesn't give too much value to business, right? Like every day writing the same code and just spending time. Why not I just create something which will not just help me, but all my colleagues in the whole org, right? And people acknowledge that fact, and that's how it is being used now.
Probably this is the most important question of this conversation. How do you call it? Chain of disaster? If it's a if it's a pattern.
Yeah, I think so. I in general, like we just call it as an exception library, right? Like people do. And I know, like I've talked with a few consumers just to get their feedback and all, right? Because in Netflix, we do believe we are pretty open, right? We do get good amount of feedback. We give good amount of feedback and all that stuff to understand how do people feel about it. And again, it was not like, okay, I developed a library 3 years back and there hasn't been any change. We have been changing. We have been improving to handle more use cases like retries and all, like so. We have some new addition made like last year is like, okay, this library also give you retriable exception, kind of a variety. So anytime in your microservices logic, you think that, okay, somebody can retry, right? And then I just give you more variety to your users, right? So those kind of stuff. But yeah, I feel sometimes, just me as an engineer, I feel good when I make something which has solved problem for either the whole world, like in being in Amazon or Netflix, you always relate with the whole world. It's not just like US or somebody, right? And even as an engineer, solving problem for other engineers, that gives me good satisfaction. So when you talk, people say, oh, now I just add a line in my build.gradle, and then I start using your exception, and things just flow in how I would have expected them to fall.
Because I was just thinking that there are a lot of things that are in terms of programming, you have a lot of stuff. It's like input on one side and then calling it. And this allows you to make clean stuff and just focus on the business side of things. And then all the other stuff is just pushed aside. But the hot words these days are observability. And obviously, in the microservices world, you need to touch the context from one side to another. And especially when the exception hits the fan, you would like to know about it. How does this change the perspective, if it changes it in any way, into getting those nice distributed logs, nice traces that will allow you to make your customers happy quicker?
Yeah, it's a good point you raised it. I completely missed that part as like the observability, right? If things go fine, nobody cares. If things start breaking, everybody cares, right? Like what has happened? Because that's where the chaos and confusion happen. So this library, the interceptor has the base place, which has a context of request and now has a context of response also. And when it realizes if something has gone wrong because of whatever reason, it identifies what has gone wrong. It logs appropriate error message or warning message. And also, we also want to be sensible, like hypothetically, in the case of validation exception, we don't want to log an error as a provider in my service. I want to log a warning, right? Like, okay, somebody is using my service in a wrong way. And why I'm saying difference between error and warning is because I might have a stricter alerting on my side if the error is logged in my service versus warning. In warning, I would say, okay, alert me or page me if there are 100 warnings, right? In error, page me if there are even 5 errors. So I think this design pattern or this library gives us that benefit also. Based on the exception, it does log even today warning or error, right? Another thing is, it's not just about logs. It's also about, even now you see, is like counters, right? Like how many times certain kind of an exception happen. And not only that, from which caller. So you can have all this information combined and you can start emitting counters. And what you can do is you can put a nice chart at the end of a week or end of a month or end of like on-call shift or something. Oh, this particular caller is misbehaving. Maybe they are out of state. They are doing something which they shouldn't be doing, or they are not understanding our business use case. And so that you can say, okay, this caller consistently hitting our validation exception, right? And then now you see the nice graph. So it's easy to pinpoint. So you don't even sometimes need to go to logs. You can just go to the charts and see, okay, which caller is causing more problem, or is there something which we don't know but silently failing on our end? Then this such kind of callers are calling us. So again, agree to your point, like observability is big part, right? Like something which will play a big role to maintain the health of your service.
Okay, so to just sum it up, it's another level. It doesn't matter. The interceptors are doing their job, and then the information bubbles up, and then you just see it nicely in the dashboard. For my final point, how do you choose? So now we are going back to the greenfield side. We are in front of a white piece of paper, and somebody says, look, you need to do another microservice that does something. How do you choose the best protocol, or what are the things that we should care when doing that? Because somehow we managed to put it like, okay, if it's coming from outside, we're gonna use this protocol and that and that. What should you bear in mind when choosing that protocol?
I guess I touched upon it a bit earlier, but my rule is kind of little simple, because obviously there is no right or wrong, to be honest, like in our computer science world as things have evolved. If I have to expose something external and which is going to make use of my multiple of my services, I would go over the GraphQL. But obviously there is a drawback to it, right? Like GraphQL doesn't support like as far as I know, and pardon me if my knowledge is not up to date, but we have had a tough time using GraphQL to upload and download files and all the stuff, right? So that's where we'll go with the rest. If I'm building new microservice, that's my policy. Like if there are internal callers to my service and I'm exposing an API which is going to be called like 100 TPS or something, by default, I'll go with gRPC, right? And it's not just about the efficiency of the protocol itself, like inbuilt structure, like you can easily drive retriability and all those kind of stuff, like by property. Obviously, Netflix has evolved a lot, so we have an internal framework to handle it. But gRPC gives all the stuff out of box, and I'm more open for retries and all the stuff for my internal services because I trust the quality of service. I trust that they do understand my use case better or pragmatic better, and that's why what they're gonna do is like I would have gRPC so that I can serve them the best.
Okay. Any other point from your side? That's something that I should have asked you, but I didn't, and that will be worth to listen to.
I think you covered majority stuff. In fact, the observability part was pretty good. And I know while building that library, I spent good amount of time in thinking through it, not implementing, but the thinking through. Majority of time in our world, implementing doesn't take much time, but the thinking through the process, right? Like how do we go about it takes time. So that was good. And again, I would say in general, like in computer science, and that's how I feel. Like if you think that you are trying to solve a problem which is generalized and it's not just scope to your service, it can help your organization or your team. Try to think of an idea, like try to think of a way so that others can make use of it. Again, in today's fast moving world, it's an advantage for everyone if they don't write the same code every other day.
Yeah, well, how I think we can frame this is that even boring stuff and annoying stuff like error handling can provide an engineering challenge. And then if you think outside of the box, will make the life easier for you, for tomorrow, but also for your colleagues. And I think that's important to follow because in the end, we do have quite a major impact around the world. I'm just thinking now about the CO2 emissions. We are quite big as a software industry. And I think each and everything that we are just doing together has actually an impact, as you said, for your colleagues, but also for the environment around it. Thank you for your time, Jenny. It was a really good conversation.
Yeah, it was nice talking with you, to be honest. It refreshes everything in my mind, what I was thinking through it. And obviously, I've talked with people in Netflix, but even outside, right? You are not part of Netflix, but you also echo the feeling that, okay, exceptions are important. User experience is important. And exception is one of the way you can drive those user experience.
Well, that's very nicely put because in the end, the trend is that just think about the car, right? It's running always or any kind of of transportation. But if it doesn't drive or work exactly at that particular point of time when you need it, that exception is problematic. So I think that's the case for most of the things. And that's why outliers are important and we should handle them with care and gracefully, of course. Thank you.
Thank you.